Do you remember the product law from grade 9? That if you had x to the 7 times x to the 3, this would equal x to the 10. And why does that happen? Well, the x to the 7 really means, oh, why did I use 7? Oh, and the x to the 3 would look like that. And in the end, you would have 1, 2, 3, 4, 5, 10 x's. It makes sense that you should add your exponents. If you think about what an exponent means, x to the 7 means 7 x's all multiplied by themselves, and x to the 3 also means 3 x's all multiplied by themselves. So we get and add the exponents. But this doesn't have to just stay with whole numbers. You could do x to the half and x to the half. Now, x to the half, we don't know what that looks like right now. Because an exponent means repeated multiplication. So when you have an x squared, it makes sense that it's x times x, because that's repeated multiplication. How do you repeat multiplication if you just had a half? It currently doesn't make any sense. But if I use the exponent rule, what would happen if I added a half and a half? I would just get x to the 1. And now, we also look at what would happen if you did a square root of something times a square root of something. Let's start with a number. Madden, pick a number. 5. If you did the square root of 5 times the square root of 5, we've learned from our square roots that a square root times a square root means you can multiply them inside. And what's 5 times 5? 25. But this is a rational number. What is the square root of 25? It's just 5. Fancy. So does it make sense that the square root of x times the square root of x will be the square root of x squared, and the square root of x squared will just be x? And something fascinating just happened. We just found out that when you have a fraction of 1/2 for an exponent, it's the same thing as a square root. Let's double check this with our calculator. On your calculator, I want you to write 81 to the exponent of 1/2. And I want to see if you get, because I know the square root of 81 is 9. I want to see if your calculator tells you that 81 to 0.5 comes out to 9. Worked on yours? Anybody have a scientific calculator that they tried? Did it work on yours? 81 to the 1/2, 9, perfect. So this is cool fact number 1. We can change, if we want to, square roots to fractional exponents. Let's see if it works with cube roots. If you did the cube root of 2 times the cube root of 2 times the cube root of 2, you would get the cube root of 2 times 2 times 2, which is 8. And that is just equal to 2, because 8 is a perfect cube. If you did a third, and multiplied by a third, and multiplied by a third, and you use the adding exponents law, can you see that you would get 1/3 plus 1/3 plus 1/3, which adds up to 1. And if I did the cube root of x times the cube root of x times the cube root of x, I would get the cube root of x cubed, which is also just x to the 1. root is the same as x to the 1/3. Now you guys are pretty smart, but I'm going to try to see if I can get one to trick you. What do you think the 7th root of x would be as an exponent? If the square root is x to the half and the cube root is x to the third, what do you think the 7th root would be? It is x to the 1/7. Oh, all right. Are you ready for some mental math? We'll start it off not so bad, okay? I would like you to tell me what's this equal to without a calculator? 49 to the 1/2. 7. Okay? You've answered the question. You're not allowed to answer the next one. How about 36 to the 1/2? 6. You've answered your question. You can't answer the next one. You're right. This is 6. Ooh. What about 27 to the 1/3? It's not 9. It's not divided by 3. You said one already. You can't say another one. I can say 3. You're right. Because this is asking for the cube root of 27. What times what times what? 3 times 3 times 3 will be 27. How about 32 to the 1/5? You've answered one already. You don't get to answer another one. It's 2. Because 32 to the 1/5 is like asking what's the 5th root of 32, which is asking what times what times what times what times what is 32. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. I can tell you mental math-wise, when you get to bigger numbers, almost always the answer is 2. Because when the number gets bigger, they don't really expect you to know like 5th roots of powers of 5 or 5th roots of powers of 6. The only powers that you can do mental math that are really easy after 4 are like 2. But now we are going to have a little bit of fun. The little bit of fun that I'm going to get you to do is I'm going to get you to do in your head what's 8 to the 2/3 and what's 32 to the 3/5. 8 to the 2/3. Okay? And we're going to review a couple of our exponent laws from grade 9. You remember the exponent law that says an exponent to an exponent is multiplied. So 8 to the 2/3 is really 8 to the 1/3 squared. And if we already figured out that 8 to the 1/3 was 2, 2 squared is 4. Okay? What's also really cool is if you do the prime factorization of 8, which is 2 times 2 times 2, and take 2/3 of it, you get 4. 32 to the 3/5. Exponent laws from grade 9 would say I could do the 1/5 first and then cube. We already figured out 32 to the 1/5 was 2. What's 2 cubed? Not 6. 2 cubed is 2 times 2 times 2. This will be 8. If you do the prime factorization of 32 and take 3/5 of it, you get 8. I don't know. I think that's super cool. But we have that These are the same. They are both 1/3 and 1/3. And in general, a square root is a half. And in general, you know that you can only square root positive numbers. Square roots of negative numbers are impossible. And with cube roots, we get 1/3. So we can fill in this chart that a half is a square root. A third would be a cube root. A fourth would be a fourth root. And a fifth would be a fifth root. So 1/n would be an nth root. And now we can change any square root that we have into a fractional exponent. And if you have exponents that are fractions, you can use your exponent laws that you have from grade 9. This is going to be really, really powerful. You want to play around with this for a little bit? Okay. We'll play around with it a little bit crazy. On your calculator, I want you to take the cube root of the square root. Let's see what's a nice number. Of 37. You're going to get a decimal answer. We're playing around with this a little bit crazy. This? This one here? Or this one? No. This one. That one, yeah, it kind of looks like a good one. It means belongs to, it's like an E because it's also is an element. So it's supposed to look like an E for the word element. But we're only talking about n as natural numbers. So we're not going to have a 1/3 root or anything like that. We're just talking about third root, fourth root, fifth root, sixth root, seventh root, and so on. So that's what that NEN stands for. Good question. Okay, we're going to play around with this. Wow, not that. We'll play around with this part. First of all, can you figure out how to type this into your calculator? The cube root of the square root of 37. Okay, so this is a little bit of calculator practice. Whichever calculator you have, my calculator, I can get cube roots here, cube root, and then inside I'm going to put a square root of 37. And push enter, and find out that the answer is 1.825. Now I'm going to play around with this with the new rules I just learned. With the new rules I just learned, a cube root is a 1/3. A square root is a 1/2. So I can change a square root to an exponent of a half, and I can change a cube root to an exponent of a third. And then I have exponent laws. What's the exponent law for an exponent to an exponent? No, multiplies. So this should equal 37 to 1/6. So I'm going to check that on my calculator. If I do 37 to an exponent of 1/6, do I get the same answer? I do. That makes me happy. I'm not making up stuff. I should do that once. Teach you a whole lesson on just make up stuff and see if you catch on. But none of it works. Would you like that? No. My little trick on you. Yeah. So now on, you're not going to trust anything I say. You're going to have to verify it all. But then if this is true, can you see that I could change this back to a square root? That would be a sixth root of 37. So is the cube root of a square root the same as a sixth root? Let's find out. Go to our calculator, and I'm going to do number 5 here. I'm going to do the sixth root of 37 and see if I get the same answer. I'm not making stuff. We're getting complicated math. You see that I could make stuff up? Blair, do you think you'd catch it if I make stuff up? No. So let's do some of this. Maybe you've already worked ahead and started these already. I'll give you a 1-minute head start for these three. Here is the answer to the first one. The green is optional. You have the option, if you like, you can change it to the square root of 49. But some people just do that in their head. And then say the answer is 7. If you like to write down the green, maybe in your notes it's nice to help remind you that it's the same. But I would be fine if you just were able to do that in your head. Negative 27 to the 1/3. That's optional. And with a negative, can you see that negative 3 times negative 3 times negative 3 would be negative 27. And same thing for this one. You could do this as an option. You can never have negatives inside of square roots, but negatives inside of cube roots is fine. Because here, you would get negative 2 times negative 2 times negative 2 is negative 8. And we've talked about this exponent law already. An exponent to an exponent. It means multiply. And maybe you can see it means multiply. And this is what I would tell anyone. Anytime you think, maybe I forgot an exponent rule. Because that may happen to you at some times. Or you might be a little bit unsure of your exponent rule. Okay? Right? The exponent rule here says multiply. But if you use nice numbers, and you think about what an exponent means, the 4 means you're going to have this same thing 4 times. That's what an exponent means, repeated multiplication. And the squared means that, oh my goodness, my dog's in the wrong spot. I have repeated multiplication of that. When I put that all together, it makes sense that I have 8 x's all multiplied together. When I write it this way, it's pretty obvious that you have 4 2's, and 4 2's is going to make 8 of them in total. So all of your exponent rules, yes, it's good if you have them memorized, but if you have them memorized and can't refigure them out, you you are going to forget them and they're going to go away when you need them. If you're unsure, using nice numbers can help you refigure them out so that they make sense. All of your exponent laws will make sense based on the definition of exponents with nice numbers. Once you start working with not nice numbers, your exponent laws still work. They just don't make sense as easily. So here is where it makes sense. But when we get to this, it's a little bit confusing. Like, how do I have 4 to the exponent of 3 halves? How do I write 4 multiplied by itself 3 halves times? That doesn't make sense to me anymore. But we can break this up, and usually it makes sense to do the fraction part first. The square root of 4 is 2. So the 4 to the 1 half will just be 2, and then 2 cubed is 8. Okay. Here's the green step if you needed it. Do you see how I skipped the green step this time? I just didn't do square root of 4. I was like, I know it's a square root of 4. It's going to be 2. (32 to the 2/5 is equal to 32. I would do the 1/5 first and then square. I'm going to skip the green step, but I'll write it down anyways. I'm not really skipping it. But the green step here would be like, this is the 5th root of 32. What times what times what times what is 32? It's 2. And then 2 squared becomes 4. Okay. Why is it important to do, you could have done this, all right, let's just, can you see that 1/5 times 2 is the same as 2 times 1/5? This is not recommended though. By the way, what is 32 squared? Anyone? No? You don't know your 32 times table? What's 32 squared?
I just said what?
That's what I'm trying to figure out.
Oh, I think
Hi, could you please send Dorinda to the office?
Yeah.
Thank you.
what? Yeah, I'll know the answer.
All right. I'm going to go with, I think it's over 1,000. 1,024?
It's actually 1,032.
Oh, I got it wrong. And then, do you know the 5th root? Wait, I mean, we can cheat. The 5th root of 1,024 happens to be 4. Can you see that the method here on the left is way better than the method on the right? If you do the squaring first, your numbers get huge. And then square rooting after makes them small. Better to make them small first and then huge after, but it is not wrong. Oh, I've got a controversial example coming up. So in general, that if you have a fraction, I would do the nth root first to the exponent of m, which means do the nth root and the exponent of m. Okay? And if n is an even number, you cannot square root negatives, you cannot 4th root negatives, you cannot 6th root negatives. These are all things that are not allowed. Which, here we've got some mathematical controversy coming up. What is this equal to? Okay. Method 1, I'm going to do this. Method 1, I'm going to say that this is equal to, you don't have to write this down yet. Oops, put the bracket in the wrong spot. If I do the 1/6 first, and then square it, I go to my calculator, and I do, I'll just do 1/6. I'll do -8 and brackets. -8 to the 1/6, and my calculator gets mad at me and says, that's not real. This is an error. So here I get an error. Method 2. I take my -8 and I square it. And then I do my 1/6. This would give me 64, because -8 times -8 is 64. And 64 to the 1/6, if I go to my calculator now and try that, 64 to the exponent of 1/6, I get 2. Oops, that's not a 6. Hey, that's exciting. So this, I get an answer of 2. And then somebody else looks at this question, and they're like, hey, 2/6, I can reduce that fraction. 2/6, would you agree, reduces to 1/3? So this makes this the cube root of -8, which you can do in your head, is -2. Oh my goodness. Controversy. So should the answer be error, 2, or -2? And the answer should be -2. So that's a little note right here. All right, this note solves the controversy.
Can you go back?
I can go back. That fraction, exponent, things need to be in simplified form. That's why your teachers say, hey, always simplify your fractions. It comes up in this situation that the answer has to be -2. Gave you positive 2. How did you write it? Oh, in this case, order of operations, it would do the 1/6 first, then the negative. So if you want to do the 1/6 to all of it, you have to put the -8 in brackets. You can try. Does that make sense? So if you wrote this into your calculator like this, your calculator does bad maths really well. Most of them do. It would see the exponent and do that first. And then the negative out front is a multiply. So if you type it in like this, you will get -2. If it has brackets like this one does, you have to put the brackets into the calculator as well. Otherwise, it will do order of operations differently. So your calculator does order of operations even when we don't want it to. Sometimes we would like it not to because we'd like to be lazy and not add brackets, but it does. All right. So we have only a couple of questions. There is a homework on page 15. You can do that over the weekend. We'll see if we can get some of these last questions done here. So the 4th root, again, I'm okay if you avoid this green step, is okay to avoid. If you went right to 3/4, quarters, I would be okay with that. So the green step says I change my fourth root to a 1/4, put everything else in brackets, and then I multiply my exponents, I'd get x to the 3/4. I'm okay. If you don't write that green step, if you can do that in your head, perfect. Maybe in your notes it's good to write down to remind yourself what's happening. And maybe early on you want to do that just to take things slowly. Okay? Evaluate. Again, I would do the 1/2 first. I don't think you need to do the green step, but if you want to, that 1/2 is a square root. So we would get 2 cubed, which is 8. Didn't we do this one already? Yeah, we have the same one twice. Wonderful notes. Who made these? Ooh. Okay. Definitely. And now we have an exponent rule from grade 9. What happened when the exponent went to multiple things inside? Do you remember? Like if you had 3x squared, again, if you ever forget a rule, think of a nice number into it. And think about your exponent rules. Like 3x squared would be 3x times 3x. Can you see that that would be 9x squared? Your 3 got squared and your x got squared. So if you can think back to what happens when I take my regular rules and I have more than one thing inside, this means the 2 is going to have the 1/3 and the b cubed is going to have the 1/3. Right? Because here, both the 3 got squared and the x got squared when it was nice numbers. So here, both the 2 is going to get 1/3 and the b cubed is going to get 1/3. Which ends up giving me 2 to the 1/3 b. You can have decimals as exponents. If you have a decimal as exponent, change your decimal to a fraction. Can you see that 2.5 is 5/2? And then I would do the 1/2 first, and then the 5. I would probably skip this green step. And just say 9 to the 1/2 is 3. Anybody know what 3 to the 5 is? Mental math, 3 times 3 times 3 times 3 times 3? 243. So see if you can do the last one. 32 to the 0.4. Can you change 0.4 to a fraction? Right? If you struggle with changing to a fraction, it is 2/5. But if you have struggled with that, that 0.4 is, in my tenths, I could do 4/10. And 4/10 reduces then to 2/5. Which I would do the 1/5 first.